Welcome to Lesson 3, where we will take our first in-depth glance at access tokens. We will discuss what they are, what information they provide, and how they pertain to Logon sessions. The objectives of this lesson are to introduce and describe access tokens, the information that they contain, and relevant API calls for managing them. We will also build on the previous lesson on Logon sessions by seeing how access tokens are linked to them. Throughout the lesson, we will also look at examples of access tokens using a third-party tool. In the previous lesson, we briefly mentioned access tokens and saw how the interactive logon process resulted in a logon session and generated an access token. But what exactly are access tokens? Access tokens are an object used by the Security Reference Monitor, or SRM, to describe the security context for a process or thread. The security context information includes information on the account associated with the access token, along with group and privilege information. Access tokens help Windows address authorization by providing a way for Windows to verify a user's level of access. The information within an access token can answer questions like, can this thread access this securable object? Or, can this thread perform this task given that the task requires these privileges? Fortunately for us, the Windows API provides several functions to query and manage access tokens. We will briefly cover some of these functions throughout the course, but first we will look deeper into what's inside an access token. What exactly is in an access token? In a nutshell, access tokens contain a variety of security context information. We'll do a brief overview of some of the key components, and you can always reference Microsoft documentation on access tokens to get further details and information. To provide examples of access token information, we use a tool called Token Viewer, which is available in Google Project Zero's GitHub repository. This tool provides a nice user interface to look at access tokens for various processes and threads. The screenshot on the right shows the main access token details for a Notepad process that was started up in a lab environment. We can see data fields like the username security identifier, or SID, for the user account associated with the token type, various ID values, and process integrity level. Note that since token information resides in kernel memory, the fields are immutable and cannot be modified from user mode except through specific system calls to modify certain fields. This will require the caller to have the required access rights. While some token attributes are modifiable in this way, attributes like privileges and SIDs are not modifiable from user mode. The Token Viewer screenshot on the right provides group information for the Notepad process token. We can see group names and some associated properties, like if the group SID is enabled for access checks or if it is a mandatory integrity SID. The group SID can also contain a special SID that represents the process's or thread's integrity level. The Logon ID flag for the second-to-last group here indicates that the group SID is a Logon SID for the Logon session associated with the token. The resource flag marks domain local groups, and the used for deny-only flag indicates that the group SID is a deny-only SID for a restricted token, meaning that when a system performs an access check using this token, this group SID can only be used to deny access, not to grant access. We'll talk more about restricted tokens and access checks in future lessons, but for now the main takeaway is that the user and group SIDs are used to determine if the process or thread with this access token can access a particular securable object. Access tokens also contain a list of privileges associated with the token, as can be seen in the top right Token Viewer screenshot. The screenshot below on the right shows the default discretionary access control list, or the default DACL. The default DACL is used along with the token's owner SID and primary group SID when creating new objects. This means that when a thread creates an object using this token, that new object's security descriptor uses the token's owner SID as the object's owner. The token's default primary group SID is used for the object's group SID, and the token's default DACL is used for the object's DACL. Access tokens are linked to their respective logon sessions via the token authentication ID, which matches the ID for the corresponding logon session. The token's authentication ID is assigned by the token creator, such as when calling the LSA logon user function. LSAS will copy the authentication ID for all tokens that descend from an initial parent logon token, which will group tokens together under the same logon session. Thus, processes can compare two tokens' authentication ID to see if they belong to the same logon session. As an example, on the right we have a screenshot of logon session output from the sysinternals tool Logon Sessions. You can see that the Logon Session ID matches up with the authentication ID shown for the notepad.exe process access token on the left. We also have parity of other information like the username, the session ID, and the user SID. The Windows API provides several functions to create, manage, and use access tokens. A small sample is shown here, and more functions with their associated details can be found in Microsoft documentation pages. Just by looking at the function names, we can get a good idea of the capabilities that the Windows API provides us. We can copy tokens using the duplicate token or duplicate token EX functions, query and adjust token information using the get token information and set token information functions, and put tokens to use with functions like set thread token and impersonate logged on user. If we want to retrieve an existing token, we can rely on functions like open process token or open thread token. As we learn more about access tokens and get some hands-on experience, we'll definitely be using some of these API calls. And don't forget that adversaries rely on these same functions as well, so we will see these functions pop up in CTI articles and attack technique pages. We have now reached the end of Lesson 3. In this lesson, we took a brief look at what's inside an access token, taking note of the various pieces of security context information. We saw how one of these fields, the Authentication ID, links the access token to the associated user logon session. Lastly, we got a taster of some of the various Windows API calls that handle access tokens, allowing us to create, manage, and use them in our applications. In the next lesson, we'll compare the two main types of access tokens, primary and impersonation. For more information, please see the following references.